All right, so we're gonna go over 6.3 real quick. Um, Notice we kind of touched these principles in earlier sections or earlier chapters. All right, so what's different is we're gonna use a little bit of factoring. All right, zeros, real solutions, x-intercepts, they all mean exactly the same thing. Okay, it's just depending on how the question is framed. Um, you respond accordingly. Okay, so let's look at this first example. All right, so we've got a function p of x equals, now you've got three distinct factors, x minus 1 times x plus 2 times x plus 5. We want to find the zeros of p of x, the solutions of p of x when it's set equal to 0. Now that's important because if they said find the solutions of p of x when it was equal to 6 or something like that, that'll change a little bit. And then you have the x-intercepts of the graph. So let's deal with the factors first. So first thing we're going to do, we're going to take this x minus 1, set it equal to 0. All right, we're going to solve that, and we get x equals 1. Take the next factor, x plus 2 equals 0. We're going to get x equals negative 2. And then this third one, x plus 5 equals 0. And we get x equals negative 5. Those are your zeros. All right, the solutions, if you look, okay, the solutions, we set all those factors equal to 0. That's what we just did here. Everything set to equal to 0. So those indeed are our solutions. All right, now graphically, we come and we look at the graph. All right, we've got an x-intercept at x equals negative 5, check. We've got an x-intercept at x equals negative 2, check. And then we have another x-intercept at x equals 1, check. So we've identified all our x-intercepts. Now the wrinkle, right, if there is one, is an x-intercept is not actually x equals 1. It truly is 1, 0, negative 2, 0, negative 5, 0. Now let's go back to that first slide. And notice the graph crosses the x-axis at a point. All right, that point is an x-intercept. So be careful with these homework questions because they can ask you for x-intercepts as points. They can ask you for or they can just have values. So, or x values that give you a function value of 0. So just be careful about reading the language of the questions. All right, so here's a quick application. And let me see if I gave myself, I did. All right, so they want us to graph this function with a viewing window that's large enough to view two turning points. All right, I'm gonna try to handle B first, and then maybe C, D, and we'll go back to the graph. So let's factor this first. So what we're gonna do, we're gonna take that function, y equals 120 x squared minus 20x cubed. Okay, we're gonna factor this. We're gonna factor out a common factor here is 20x squared. Okay, and we're going to be left with 6 minus x equals y. That's factor form. Okay, now we want to find the x-intercept. So all we do is we're going to come down here and we're going to take that 20x squared and let's clean this up just a little bit. 20x squared times 6 minus x, set it equal to 0. We're going to set each factor equal to 0. All right, It's 20x squared equals 0. That's just going to say x equals 0. All right. The right equation, what equation here, we're going to add x to both sides. And we're going to get x equals 6. Okay. So use factoring to find the x-intercepts. So again, 0, 0, and 6, 0. That's done. Now we want to graph this function. So what I'm going to do is I'm going to pull up my Desmos app. All right, we've got 120, I think it was x squared minus 20x cubed. All right, now notice I can look at it and it's like, oh, so I'm scrolling. So I need to change this window just a little bit. Let's clean it up. We're going to go with time. Let's go 0. And let's go out to maybe 10. It's a little good. That's better. And then let's drop that y to 0. Let's go 650. And let's see. I don't think that's pretty good. That's it right there. Now, got 2 turning points. Okay. If I click on this graph, there's one of my x-intercepts, 0, 0. My second x-intercept, 6, 0. My max value, okay, 4, 6, 40. So now go back. All right, so we have our graph, and it says, but non-negative values of x will give positive photosynthesis. So now, when we look at that graph, and I may be able to do it here, what I'm going to try to do is take a picture. Okay, so let me pull that picture up real quick. Now, it said what X values give positive photosynthesis. So that means we want everything. Well, let me undo that. Want everything between 0 and 6, because those are my zeros. Okay, so once you go beyond 6, you won't have positive photosynthesis. Okay, so I'm gonna go ahead and delete that. All right, let's go back to the PowerPoint. Okay, so what non-negative values of x give positive photosynthesis? Now, the way we're going to do this is we're going to say x is in between 6 and 0. Now, notice I didn't use an equal to bar because 0 is not a positive number, right? 0 is a 0. So anything between 0 and 6 will give positive photosynthesis. Graph the function, and we did that. So we did A, we did B, we did C, we did D. Real simple. And we could have graphed it from the very beginning. Now, we didn't have to factor it. We could have used the graph to find the factors. Okay. All right, so then we got another example here. The cost of producing the product is given by the function C of x equals x cubed minus 12 times x squared plus 3x plus $9,000, where x is the number of hundreds of units produced. How many units must be produced to give a total cost of $45,000? Okay, now, first thing we have to look at. All right, C of x is the total cost in thousands of dollars. All right, so how many units must be produced to give a total cost of $45,000? So the first thing we have to do is we have to take that $45,000, all right, and we have to remember that's thousands of dollars. So we end up dividing 45,000 by 1,000. And that's why we got C of X equals 45. So remember, always have to interpret the units. So what we did is we just came in, we set 45 equal to x cubed minus 12x squared plus 3x plus 9. Okay, now you had two options. In the past, we could have just graphed both y equals 45 and then C of X and saw where they intersected. Okay, so you can actually use intersection method here. You can find the intersection. I lost my pen. Let's see. Find the intersection. Or we can find the actual X-intercept. So I'm going to write this function down, and then I'm going to go to Desmos. Now, if you want to try the factor, you can. That's one of your options. But I prefer graphing just because it's a lot smoother. So go to Desmos, clear out that graph. Okay, I'm gonna hit my gear, and I think there's a little zoom square. So that's a square window. They didn't really reset it, but it just put in a square window. So we'll clean that up. And we had x cubed minus 12x squared plus 3x minus 36. All right. So now I noticed from the very beginning, see my graph's real tight, which means I need to change that window. And I'm going to clear all this out, and I'm going to go 0. And I'm not going to go out to 1100. Let's go out to about maybe 12. There we go. And then my Y is still a little too high. So let's go. Let's go 0 to about no higher than 36, maybe. Nope, need to be a little bit higher. Okay, so now notice when I look at that graph, it looks kind of funny. But I really only care about that X-intercept. So I care about that value. Okay. And we're going to verify it because I feel like it's off a little. All right. So that means 1,200 units. So let me pick that up. When I had an X-intercept at 12. Okay. So what X is the number of hundreds of units. So this answer will be 1,200 units. All right, so now let's verify that. Okay, let me show you another way to do it just because. So I'm gonna write down my original function, and I'm gonna set it equal to 45 and see if the intersection method gives me that exact same answer. Okay, let's take that out. And what we're gonna do x cubed plus 12x squared plus 3x plus 9. Okay, there's my graph. And then I want to put an intersection where y equals 45. Come out here. All right. Let's make that drop down my y's. 0. go 100. Okay, a little bit better right there. And I click and see my X values seems a little off. That's why I knew something was a little wrong. No, it's not. It's a minus here. Okay, there we go. All right, so I just had to verify that I was correct. So that's another way, intersection method. All right, so at 1,200 units, now remember you got to interpret your answer. Okay, so they told me that X was the number of hundreds of units. So that's just not 12. That's 1,200 units produced a cost or have a cost of $45,000. So what we did originally was indeed correct. All right, so we did that. Now the root method. Okay, basically and we kind of went through this with just the square root method, but again, it extends to any index. Okay, and that's what that number there is called, an index. So n could be a third, it could be a fourth, fifth, sixth, so on. But it's typically it's got to be positive. Okay, and you want to isolate your expression or your root term, and then you just use an nth root to solve. All right, so let me show you 3 quick examples. All right, so this first one, I want to solve x cubed equals 125. All right, my cube term is by itself. So to solve it, you take the cube root of both sides. Okay, cube roots and cube powers, they cancel. So we end up with x equals the cube root of 125, which is indeed 5. Okay, now example B, we got 5x to the fourth equals 80. Now we want this x to the fourth by itself. That's what we want. So that 5 needs to be divided. Divide both sides by 5. We know it's x to the fourth equals 16. All right, fourth root or fourth power, we're going to use the fourth root to cancel it. Take the fourth root of 16. Now be careful with these even numbers. Fourth root, fourth powers, they cancel. X equals the fourth root of 16 is 2, but we're going to go plus or minus 2. Okay, because negative 2 times itself 4 times is indeed 16. All right, see similar example. We divide by 4. We end up with x squared equals 18 over 4, which is, we're going to go ahead and simplify that, which is 9 over 2. All right, we're going to take the square root. Now, I'm not going to use an index, but if you really needed to, you could actually put a 2 in there. It's not going to hurt it. But square root's understood, the index is understood to be 2. And then we've got 9 halves. Okay, square roots, squared powers cancel. We get x equals. Now, you can go with plus or minus square root 9 over 2. That's fine. All right. Just make sure if you do that, that radical symbol is over the entire fraction. Now, some people will say, or they can do it like this. They could say, or it's the square root of 9 plus or minus 9 over the square root of 9 over square root of 2, which is plus or minus 3 over the square root of 2. And then my math lab has changed. In the past, you had to do what's called rationalization. All these answers, and then you would do one more thing. You would say this is 3 square root 2 over 2. Now, that all those answers are good. So you can use that. You can use this, you can use this, or you can stick with the first answer. All right, they're all the same. Okay, and then, all right, so there's this application. All right, so we want to find the future value, or we know the future value of $10,000 invested for 4 years at interest rate R compound annually is given by S equals 10,000, which is your initial investment, times your compounding rate, 1 plus R raised to the fourth. Find the rate. Okay, no problem. Find the rate as a percent. Now remember, as a percent. So we're probably going to end up with a decimal answer, but then we want to convert it. For which the future value is $14,641. All right. So it's a little bit of algebra. First thing we're going to do not distribute that 10,000. Okay. Oops. We'll divide both sides by 10,000. All right. So take a calculator. All right. You know what? We're going to end up with a decimal answer. So that's going to be 1.4641 equals 1 plus R, keep the parentheses, raised to the fourth power. So let me pull up my calculator here, because we've got to take a root. And we're going to take the fourth root of both sides. Now, we don't really want to round until the end. And this will be the fourth root. Now, notice this is an even root, so let me say this from the beginning. All right. We're not going to keep the, we're not going to even really need the plus or minus in this case, because we're talking about a percent of interest rate. Okay, so now you can have negatives, but we're going to assume they don't want negatives. All right, fourth roots, fourth powers, they cancel. Boom. All right, so now what I'm going to do is I'm not going to use my calculator yet. I'm just going to cancel this out. And then I'm going to come over here. I'm going to say the fourth root of 1.4641 equals 1 plus R. And again, just bring that fourth root down. Do not use your calculator at this point, because you will typically probably get around there. So I've got one more step. I'm going to subtract 1 from both sides. Okay. So now I'm going to pull up my calculator. And let's see if I've got it. All right, pull up my calculator. I'm going to go nth root. Got 4 of 1.4, I think it was 641. Let me verify. Real quick. 4641. Okay. 26. All right, and now we're going to subtract 1. Okay. So there's my answer. Okay. Now that's a decimal answer. So I look at it and I say 0.1. So I'll come back. R equals 0.1. But again, that is not a percent. Okay. That's a decimal. So to convert to a percent, we're going to times it by 100. So we'll take 0.1 times 100. So that's actually 10%. Okay, and I'm gonna take a calculator. I'm gonna verify my answer. I'm gonna take $10,000 times 1 plus 0.10, or 10% raised to the fourth power. And indeed, that is my answer. So I am correct. And that's how you use, I guess that's how you apply roots solutions, X-intercepts to solve polynomials. All right, so that's it.